So yesterday I discussed fundamental theorem of arithmetic with you. So I had just written this. You can start writing down and then we will start with the exercise. So the chapter is real numbers, and I think you're all familiar with what real numbers are. Last year, the very first chapter of your maths syllabus was a number system, and हमने बहुत डिटेल में पढ़ा था what real numbers are. So if I had to recall what real numbers are, any number that you use in the real world, any number that you use in the real world is called a real number, and each of those numbers which you can use in the real world can be expressed as a fraction or a decimal. So the values which can be expressed as fractions, those are called rational numbers, and those decimal numbers which cannot be converted into a fraction are called irrational numbers, if you remember. So all those types of numbers which you have been studying about since your junior classes, starting from your counting numbers, your whole numbers, integers, decimals, fractions, rationals, irrationals, all of those numbers are covered under real numbers. We are going to use some basic operations on these other than addition, subtraction, multiplication and division. We are going to work with the real life problems also. So as for now, what we have is so what we have here is the fundamental theorem of arithmetic, which tells you that any composite number, before we jump into this, I thought of discussing with you, or rather asking you whether or not you're aware of what prime numbers and composite numbers are. Because the mechanical definitions iski to discuss to kar di statement for the fundamental theorem of arithmetic. But I forgot to ask one thing, whether or not you people are aware what is. Does there anyone who's Piyush from 5th A? So anyone who can tell me what are composite numbers and what are prime numbers, so that the definition is actually clear.
And prime numbers, that numbers which are divisible by 1 and itself.
Right.
And ma'am, composite numbers, मैम जो प्राइम नंबर नहीं होते वो कॉम्पोजिट नंबर्स होते हैं.
Okay. Is one a prime number or a composite number?
One is neither prime nor composite.
But Sahed said if a number is divisible by 1 and itself, it's a prime number. So 1 is a prime number, isn't that so? This is what Sahed said, a number which is divisible by 1 and itself. I'll give you 15 seconds to think about this. Like, should the definition be fixed somehow? Like what you're saying. I know what you're trying to say here, but this cannot be used as a standard meaning of prime number. It's easier to remember this way कि कोई number अपने table में आता है और 1 के table में आता है, तो उसको हम prime number बोल देंगे. लेकिन अगर आपको किसी को define करना हो, prime number की definition which would work for any prime number that you can pick or any number which is not prime, even then. So we need to specify prime number in terms of its factors. कि अगर हम किसी नंबर को प्राइम नंबर बोल रहे हैं तो उसके कितने फैक्टर्स होंगे. So think quickly of all the prime numbers that you have. How many factors do they have, each of them? And how is one different from all those primes? That's correct, Anatpreet. All the prime numbers have 2 factors, whereas 1 has just 1 factor. Now compare the number of factors for 1, for prime numbers and for composite numbers and see what the difference is. Prime numbers के 2 factors होते हैं. The number itself and 1, exactly 2 factors. ना 2 से ज़्यादा, ना 2 से कम. Exactly 2 factors. Then if you look at composite numbers have more than 2 factors always. 1 is a factor of every number. The number itself is a factor. फॉर इटसेल्फ ये दो फैक्टर्स तो पक्के होंगे. सो प्राइम नंबर्स के पास सिर्फ ये दोनों ही होते हैं, एक 1 होता है उनके पास और वो खुद है. Whereas composite numbers have at least one other factor than 1 and itself. For example, if you take 4, 4 is the smallest composite number. So 4 के अगर हम factors लिखते हैं तो हमारे पास factors बनते हैं 1, because 1 is a factor of every number. Then the other factor that we have is 4, the number itself. And then the third one is 2. 1 और नंबर खुद, इन दोनों के अलावा अगर हमें एक और फैक्टर मिल जाए, मींस हमारी जो फैक्टर्स की लिस्ट है उसमें 2 से ज्यादा मेंबर्स हों, तो हम उस नंबर को बोलेंगे कॉम्पोजिट नंबर. So this is the basic definition or the difference between composite and prime numbers, that a prime number will always have exactly 2 factors. Exactly, the word exactly means na 2 se zyada na 2 se kam. And how does that help you using the word exactly? मतलब उससे फर्क क्या पड़ा? उससे ये फर्क पड़ा कि जब मैं बोल रही हूँ कि 1 has 2 factors, 1 and itself, does that make it a prime number? No, because वो सिर्फ repetition हो गई, but factor actual में एक ही है. 1 के अगर हम factors की list बनाते हैं तो उस list में सिर्फ एक ही factor list होगा, 1 only. That's why 1 is not prime, not composite. I hope it's clear.
Yes, ma'am.
This is a trick question actually when somebody asks you to define a prime number. So the first thing that comes to mind is prime number is a number which has 2 factors, 1 and the number itself. So the person asking you could, simply argue with you that by your definition, 1 is a prime number. So you should know. So when you say a number is a prime number, that means it has exactly 2 factors. Composite number will have more than 2 factors. And since 1 has just 1 factor, now वो prime बना, now वो composite बना. And fundamental theorem of arithmetic says कि अगर आपके पास कोई composite number है, आप उसकी prime factorization कर सकते हो, और prime factorization same होगी अगर हम factors का order ignore कर दें. और अगर सभी को ये कंडीशन दे दी जाए कि उन्होंने जब प्राइम फैक्टराइजेशन करनी है तो उन्होंने इंक्रीजिंग ऑर्डर में अपने प्राइम फैक्टर्स को अरेंज करना है, तो प्राइम फैक्टराइजेशन एग्जैक्टली सेम होगी फॉर एवरी पर्सन हु हैज डन द प्राइम फैक्टराइजेशन करेक्टली फॉर द गिवन कॉम्पोजिट नंबर. आई हैव टेकन द एग्जांपल of 90 and I have done the prime factorization 2 ways, in which like I have started with the way teachers tell you कि बेटा smallest prime factor से शुरू करो. तो उससे अगर हम करते हैं तो हमारे पास बनता है 2 into 3 into 3 into 5. एंड देन अगर कोई डायरेक्टली सोचे 90 ये 0 से एंड हो रहा है तो ये 5 से डिवाइड हो जाएगा, तो 5 से कोई शुरू कर दे, फिर 18 आ गया, फिर 18 इज अ इवन नंबर तो 2 से डिवाइड कर दिया, तो ऑर्डर चेंज हो जाता है, लेकिन आपकी प्राइम फैक्टराइजेशन एग्जैक्टली सेम है. एंड व्हाट वी आर गोइंग टू प्रेफर इज कि हम जो प्राइम फैक्टराइजेशन लिख रहे हैं उसको हम एक्सपोनेंशियल फॉर्म में एक्सप्रेस करें. आपके पास जितने प्राइम फैक्टर्स आएंगे आप उनको एक्सपोनेंशियल फॉर्म में लिखोगे. द पावर 1 कैन बी इग्नोर्ड, बट आई सजेस्ट कि आप लिख लो. जहाँ पे सिंगल टाइम कोई फैक्टर आ रहा है उसकी पावर 1 मेंशन कर दो, नहीं करोगे तो भी ठीक है, बट ट्राई टू राइट द प्राइम फैक्टराइजेशन इन दिस वे. द वेरी फर्स्ट क्वेश्चन इज द प्राइम फैक्टराइजेशन ऑफ नंबर्स. So we are going to take you back to class 5th or 6th, where you learned doing the prime factorization for the first time. And then in 8th standard, you learned how to write down that prime factorization using exponents. अगर आपके ब्रदर सिस्टर, आई थिंक देयर आर अ फ्यू स्टूडेंट्स जिनके सिबलिंग्स 8th में हैं, तो दे कैन टेक अ लुक एट द चैप्टर ऑफ एक्सपोनेंट्स एंड पावर्स. उनके पास ये क्वेश्चन था, express the following numbers as the product of primes expressed in exponential form. So to write down a number as product of primes would mean prime factorization, and then the product, since it's repeated, can be expressed using exponents. So this is how we are going to do our questions. Afterwards, we will be using this fundamental theorem of arithmetic to find out the HCF and LCM of the numbers. So before we take this, page number 9 or 10. This is page number 10. We have HCF and LCM of two numbers. So HCF means the highest common factor. LCM means the least common multiple. So the word uses the words factor and multiple. So can anyone define what a factor and a multiple is? Anyone who can tell me what a factor and multiple is? You can quote an example if you want to explain that.
मैम फैक्टर जिसके साथ नंबर डिविजिबल हो.
Yes, completely divisible. Remainder should be 0. And what about multiple?
Multiples are what we get after multiplying the number by an integer.
That's correct. When you multiply two numbers, the answer obtained, the product, will be called the multiple of each of those numbers which have been multiplied. So if I had to just write down, this has nothing to do with the work that you want to note down. So if I write down 9, or let's take any other number which could be written in a different way. Let's take 20. So 20 can be written as 1 into 20, 2 into 10, then it can be written as 4 into 5. So the ways it can be expressed, the list appearing on the right hand side are all factors of 20, whereas 20 is a multiple of all the numbers whose product gives you 20 as the answer. So 20 is a multiple of 1, 20 is a multiple of 20, 20 is a multiple of 2, because 2 को 10 से multiply करें तो 20 आंसर आता है. So any number whose product gives you 20 as answer with some number, doesn't matter किससे multiply कर रहे हैं, multiplication करके आंसर अगर 20 आ गया तो हम बोलेंगे 20 is the multiple of that number. And if you carry out the division, remainder is 0, there is complete division, then we say that the divisor is the factor of the dividend. ये बिल्कुल basic definition है, लेकिन the important thing is factor and multiples go side by side. हम सेम ही चीज को एक फैक्टर के वे से बोल सकते हैं और एक बार हम मल्टीपल के वे से बोल सकते हैं. Okay, Agam Rup, better try connecting again. ये problem बहुत ज़्यादा आ रही है. I think yesterday, if you people were present in the meeting, there was one child who mentioned this, that this problem is being faced
Yes,
by so
ma'am.
many students. Yes. So
Yes,
and
ma'am.
the child actually suggested to move to some other platform, and maybe we will shift to Google Meets. Let's see. We will have to find out a way to record the class. All right. So right now, simply thinking of just trying to understand, whenever you have the product of two or more numbers, the answer is called the multiple of those numbers, and the numbers which have been multiplied are called factors of the product. I hope I'm making sense.
Yes, ma'am.
Okay. Because
Yes,
to
ma'am.
me it always makes sense. It's you people who you have to understand, right? So let me know if you can follow what I'm saying. So when we say HCF and LCM, we will be focusing on the HCF and LCM of two numbers, although you can find out the HCF and LCM of multiple values. हम सिर्फ focus करेंगे the HCF and LCM of two numbers. So if you have to find out the HCF of two numbers, you are looking for the common factor, the highest common factor. That would mean the highest number or the largest number by which each of the numbers are divisible. So if you want to find out the HCF of 4 and 20, so you want to find out the largest number by which each of these will be divisible. So वैसे ये दोनों 1 से भी divide हो जाएंगे, 2 से भी हो जाएंगे, 4 से भी हो जाएंगे. But largest कौन सा है इनमें से? 4. So 4 is the HCF. And when we are trying to find out the LCM, that means the least common multiple. That means the smallest number, which is the product of each of the numbers here. So if I again had to write down the LCM for 4 and 20, अब 4 के multiples बनते हैं 4, 8, 12, so on. Whereas 20 के multiples बनते हैं 20, 40, 60, so on. तो इनका अगर हम कॉमन मल्टीपल ढूंढ लें, द फर्स्ट कॉमन मल्टीपल, जो सबसे छोटा कॉमन मल्टीपल होगा, दैट वुड बी 20 itself. So the HCF is 4 and the LCM for these two numbers is 20. You have done this. Yes?
Yes, ma'am.
Now, there were 2 or 3 methods which you have learned to find out the HCF and LCM. 2-3 तरीके थे जो आपने अपनी क्लासेस में, जूनियर क्लासेस में यूज किए हैं to find out the HCF and LCM of any two numbers. But right now we will be working only with prime factorization in order to use the fundamental theorem of arithmetic. Fundamental theorem of arithmetic use करेंगे तो जो numbers हैं, they will be written as the product of primes. And once you have done that, आपने numbers की prime factorization कर ली, उसको use करके जब आपने HCF और LCM लिखना है, what you will be doing is, for the HCF, now H stands for highest, but we will be taking the smallest power of each common prime factor. And then for LCM, we will be taking the product of the largest power of each of the prime factors, doesn't matter whether it's common or not. And then there is this result which is very important, that if
उस तो पहले कौन था ना
just Karanjeet. So if we have two whole numbers means आपकी बुक में इसको ऐसे लिखा हुआ है पॉजिटिव इंटीजर्स. सो अगर आपके पास कोई दो पॉजिटिव इंटीजर्स हैं, होल नंबर्स हैं, the HCF of those two numbers multiplied with the LCM of those two numbers will give you the same answer as the product of the numbers. Like right now मैंने अभी एग्जांपल ली थी 4 और 20 की, इनका HCF 4 आता है और इनका LCM आता है 20. So if you multiply the HCF and LCM, it is equal to the product of the numbers itself. Just Karanjeet, beta, your mic was unmuted and we could hear your conversations. That's why I called you out. Your first exercise is completely based on what you have here. You can unmute and answer, beta, it's okay. It's all right. Let's just start with the questions from the exercise. Exercise 1.2, it's on page number 11. Question number 1, you have to find out the prime factorization for each of the numbers given to you. And the question says express each of the following numbers as the product of prime factors. So this statement should tell you to do the prime factorization of each of the numbers. So जो काम आपने बचपन में किया था अभी आपको वही करना है, and you have to show the prime factorization in the fair work. So the first value that we have is 140, and I'll be doing one with you. The rest of the numbers you will be doing on your own. And I suggest that you write in ascending order of prime factors. So you start with so 140 can be expressed as the product of 2, 2, 5, and 7. And I would like you to write this as 2 squared multiplied with 5 raised to the power 1 multiplied with 7 raised to the power 1. Anyone who does not know how to do the prime factorization? Okay. So I'll be giving this as homework to you. And at any point, if you feel like you want to ask something from what I'm giving you as homework, please ask. Question number 2. Find the HCF and LCM of the numbers given. You have been given pairs of integers here. And then you need to verify this result that the LCM multiplied with the HCF is equal to the product of the numbers. So again, I'll be taking up one part and you'll be doing the other to yourself. And you can simply let me know which one should I do with you. Let's do second one.
Yes, ma'am.
So the numbers are 510 and we have 92, and we want to use prime factorization. So the first step will be to do the prime factorization. And you don't need to write this actually. This is only for you to remember. Prime factorize each number. So 510 and 92. So we have 2 multiplied by 3 multiplied by 5 multiplied by 17 for 510. For 92, we have 2 multiplied by 2 multiplied by 23. Let's first of all find the HCF. To find out the HCF, we look for the common factors always. So this is the HCF. And when we want to write down the LCM, we like to take the common factors as well as the ones which are non-common. So take the factor which is common, it's 2. And other than that, baki jitne sare factors reh gaye, all those will also be taken. Find out the product.
$23,460.
Yes, ma'am. 23,460.
So we have the HCF and we have the LCM of the numbers. This is first part of your question done. And after this, we want to verify the result that HCF into LCM is equal to product of numbers. So let's multiply the HCF to with the LCM, 23,460 on one side, and on the other side I'm going to multiply the numbers themselves and see if the answers match.
$46,920.
So the product of the HCM and HCF and LCM is 46,920, and the product of the numbers I think should be same. It is also 46,920.
Yes, ma'am.
Right? So as you can see, the two answers are same. So you can write down, hence it's verified. Anyone with any questions here? Okay, I would like you to just take a look at how they have done in book when they want to write down the HCF and LCM. Just for understanding, you should know how they are writing this down. So you had 510 equals to 2 into 3 into 5 into 17, and 92 was the product of 2 multiplied by 2 multiplied by 23. तो अगर हम इनको लिखते हैं in exponential form, this will simply be each factor appearing once, so इनकी power 1 आ जाएगी, whereas in case of 92, 2 has been written twice, so it will be 2 squared with 23 raised to the power 1. तो अगर हमें ये powers को use करके HCF को लिखना हो, तो हम लेते हैं हमेशा the smallest power of the common factors. So you want to pick smallest power of common prime factors. सबसे पहले तो ये चेक करो कि कोई प्राइम कॉमन है भी या नहीं. सो कॉमन प्राइम फैक्टर इज 2 हियर, और इसकी स्मॉलर पावर कौन सी है?
1.
सो दैट विल बी योर HCF. एंड जब आपको लिखना है LCM, यू आर गोइंग टू टेक द लार्जेस्ट पावर ऑफ ईच प्राइम फैक्टर. आपको जितने प्राइम फैक्टर्स नजर आ रहे हैं उन सभी की आपको हायर वाली पावर लिखनी है. तो अगर हम पहला प्राइम फैक्टर चेक करें 2, उसकी हायर पावर है 2, सो यू विल बी टेकिंग 2 स्क्वायर. देन वी हैव 3 विद पावर 1 बिकॉज यही एग्जिस्ट कर रही है. फिर 5 है हमारे पास, फिर 17 है, और फिर 23 है. And if you go back and look at the way you have done, you will see कि exactly वही चीज लिखी है हमने. The only difference is यहाँ पे हमने exponential form में लिखा है. अगर आपको कहीं किसी बुक में इस तरह से लिखा हुआ मिल जाए, so don't think कि ये तो मैम ने करवाया नहीं हुआ. Alright, you should be aware of how this can be done using exponents. And just take a look at the example right before this exercise, example number 6, and you'll understand what I'm talking about. और जरूरी नहीं है कि आपको पावर्स लिख के करना है, आप उसी मेथड से कर सकते हो जो भी हमने क्वेश्चन में यूज किया है. बट यू शुड बी अवेयर ऑफ हाउ दिस कैन बी रिटन. समटाइम्स इन 1 मार्क क्वेश्चंस और इन MCQs नंबर्स को इस तरह से एक्सप्रेस किया हो सकता है. HCF लिखा हो, LCM लिखा हो इस फॉर्म में, और आपको पूछा हो कि ये करेक्ट है या नहीं, एंड यू गेट कंफ्यूज्ड. सो यू शुड बी अवेयर. Now I'm going back to the exercise. Question number 3. Find the HCF and LCM of the following integers by applying prime factorization. So the first group of numbers is 12, 15, and 21. Let's do the prime factorization for each of these numbers and then find out the prime factorization. For question number 2, the remaining 2 parts you will be doing on your own. So I'm simply going to write down 12. This will be 2 multiplied by 2 multiplied by 3. Then 15 will be equal to 3 multiplied with 5. Then 21 will be equal to 3 multiplied with 7. I have deliberately arranged my factors in this way so that they fall below the common pairs. Like you can see them in columns of being common with each other, so that it's easier to write down the HCF and LCM. For the HCF, always take the common factors. What will be the HCF here?
3.
So the HCF will
3.
be 3. And when you write the LCM, you're supposed to take the ones which are common, whether they are common for all 3 or they are common for 2 of the numbers, or they are not common for any of the pairs. So you will have 3 multiplied by the rest of the factors. So you'll have 2 multiplied by 2 multiplied by 5 multiplied by 7. 420?
420.
That's it. This is what you have to do in question number 3. Now you might be thinking ये 10th की पढ़ाई तो लग ही नहीं रही. How many of you are feeling this way? Like why we are doing this right now, which we have done in class 6th and 7th, maybe in 4th and 5th as well. right. Moving on, question number 4. You have been given that the HCF of 306 and 657 is 9. LCM of these numbers needs to be calculated. So this means HCF of 306 and 657 is 9. LCM of 306 and 657 you have to find out. And for this, we are going to use the result that we have, that for any two positive integers, the product of HCF and LCM is same as the product of numbers. So we are going to write down that we know HCF into LCM is equal to product of numbers. And then just use the values. So 9 multiplied by LCM equals to the product of the numbers. And then solve your equation.
$22,338.
I think this gets cancelled here. 73. And then you can multiply 306 with 73. Yeah. All right. Question number 5th, we will be doing later after we complete the remaining questions. So question number 6th right now, explain why these numbers are composite numbers. Let's take a look at the numbers that we have. Question number 5th is actually a prove that result. तो ये हम बाद में करेंगे. Right now I'm taking question number 6th. You want to write down why these two numbers are composite numbers. So we are going to use the definition. Definition of a composite number says that it has more than two factors. So if we can somehow prove कि यहाँ पे जो number लिखे हुए हैं, the way they have been written, इन numbers के 2 से ज़्यादा factors हैं, तो हम बोल देंगे कि ये numbers composite numbers हैं. And to do that, there are two ways. One is to simplify and evaluate कि ये number बनता क्या है, और फिर बाद में उसकी आप प्राइम फैक्टराइजेशन करके दिखा दो कि इसके तो बहुत सारे फैक्टर्स बन रहे हैं, तो ये कॉम्पोजिट नंबर है. The other way is only the way it is simplified can be changed by using distributive property. When you want to evaluate your number, you can use distributive property in order to reduce your work. So I will be showing both methods. For the first one, I've got 7 into 11. Please note down the numbers carefully and the operations. Plus or multiply ध्यान से note करना. So I'm going to first of all use my simplification. So the product of 7, 11 and 13 becomes 1001. Adding 30 into it, this becomes 1014. And if you prime factorize 1014, this is what you get. This is one way of doing it. And then the second method is use distributive property to simplify. So we have this. 13 is common. Let me know if this makes sense. Which one
Yes,
do you
ma'am.
think is easier, like the first one or the second one?
Second
First
one.
one.
Okay.
The second
So
one.
we will have, yeah, we will have different choice of preference here. So you can do any way. पर्पस बस ये है कि आपको दिखाना है जिस नंबर की बात हम कर रहे हैं उसके 2 से ज़्यादा फैक्टर्स हैं और वो 2 फैक्टर्स जो पक्का ही हर नंबर के पास होते हैं वो होते हैं 1 एंड इटसेल्फ। तो जो फैक्टर्स दिखने चाहिए वो 1 और द नंबर इटसेल्फ के अलावा कोई और दिखना चाहिए और अगर आपको एक भी और मिल जाएगा ना तीसरा फैक्टर द नंबर विल बी कॉम्पोजिट। And I think now you should be able to do the second part of this question, which is 7 into 6 into 5 into 4 into 3 into 2